display mode there. So my name is William Dixon. I'm here with Mark Simos and Solomon Lukey. Mark and I are Microsoft Consulting Service consultants. We are on the cybersecurity team. And our mission is to look after the threat, to sort of understand the threats that are facing customer environments and come up with specialized solutions to help address those threats. So what you're going to see today is a talk that we were very excited to put together and to deliver. And fortunately, we're joined by Solomon Lukey, who is the owner on the the software development team for a feature that we're going to show exclusively here in TechEd today, called the Attack Surface Analyzer. So it hasn't been presented at TechEd yet, and it's only going to be covered in this talk. And we're going to try to breeze through the first part of the talk to give Solomon lots of time. So thanks, Solomon and Mark, for being here. So as I mentioned, the outline that we're going to cover today, in case folks have to take off early, we're going to do a brief introduction to cybersecurity the way we see it, and then we're going to talk a little bit about group policy, a little bit about Security Compliance Manager, cover a new tool called the Enhanced Mitigation Experience Toolkit, EMIT, talk about AppLocker for a few minutes, and then finish with Attack Surface Analyzer. So that we can sort of gauge the right amount of time to spend on things, I was wondering how many folks here have used Security Compliance Manager, SCM, as a tool to build security baselines? Okay, not so many. How many have used EMIT yet? A few. Okay, and how about AppLocker? I've actually used AppLocker, even tested it. Just a few. Okay, so this is all pretty new stuff. Anybody here who's actually used Attack Surface Analyzer? Oh, okay, different hands and a few. Very good, thank you. So the tools that we're talking about today are all free. The two tools, EMIT and Attack Surface Analyzer, are developed by Trustworthy Computing, Solomon's group, and they're available for download. They're described in blogs and KB articles. And then the other features are just part of Windows. So Mark, I'm going to turn it over to you for cybersecurity.
Testing? Okay. So we wanted to share, so William and I focus on the endpoint space and protecting networks from, protecting workstations and admin workstations. That's one of the areas we focus on the cybersecurity team. So we wanted to share some of the perspectives that we've gained working through this area, as well as some ways of looking at it and thinking that may give you some insights into this problem space and how to solve some of the problems in it. So just to illustrate the threat here, IE8 and IE9, the smart screen blocker that's included in that, block about 2 to 5 million attacks per day. Since the IE8 release, it's been 1.5 billion attempted attacks have been blocked. So there's a lot of activity out there on the internet, in the wild, a lot of web pages that are compromised. And this was actually, I believe, in an IE blog that was posted yesterday or today. So this is all public information. And so IE9 also adds defense against socially engineered attacks and gives you a reputation, information about the downloads that you pull down. Because 1 out of 14 of them have been seen to be compromised. So the big question, because we're going to be focusing today on administrative desktops. That's the primary scenario we're going to address. And then we're also going to talk about how to take what you're doing to that small population and also expand it out to your entire enterprise desktops. So why do we care about administrative desktops? Active Directory compromise is bad. How many people here have survived a Windows AD migration and all the joy in the cleanup? How would you like to do that on a compromised network where you're not sure if the accounts in there are real or placed by the hackers? It's a rough place to be. You don't want to be in that position. It's costly. Getting to 100% assurance is very difficult, and it could also potentially be embarrassing for the IT organization as well as for the business as a whole, depending on the disclosure level. So we want to keep you from getting into that position. That's the motivation for this talk. And the enemy is well-funded and intelligent and sophisticated. They make a lot of money at this. They're getting paid to do this every day. The techniques are getting better. They're hiding themselves better. They're getting onto machines better. They're getting more efficient by putting these things into toolkits and being able to generate malware at will. As an illustration of this, Symantec reported 286 million variants that they detected in 2010. That's a lot of different kinds of malware. It kind of brings to light some of the challenges and limitations with the signature-based approach. So we'll hit that in the app blocker section. So one perspective that we think is very illustrative is looking at it from the attacker's point of view. What does the enemy want? He wants ingress. He wants to get on your network and start to do things. He wants to gain a beachhead. He wants to get his software on your machines. Probably at first as a user context, ideally as a local admin or local system context, and even better than that, he wants to expand that presence and become a domain administrator or that level of access. That is what they want to get, because then they can get redundant access. So you clean a machine, it doesn't matter to them. They still have access through all these other redundant channels. They want to be able to access your network without you knowing it whenever they feel like it, remotely, probably from some safe haven country. And they want to implement their goals. That's the final step. Whether they want to steal your data specifically, whether they just want to use your machines and your internet resources to launch other attacks or to hide themselves during another attack. But they have a payload and they have a motivation for going through all this effort to get onto your network. So that's just a perspective on how they look at it. Another one that we feel is very interesting is taking an economics perspective. And this is economics from the standpoint of me, the defender. And so on this curve here, you got 2 points of interest. And defender cost is what it costs me to defend my network. Benefit is what I get for assurance out of it. So along these lines, you have a point of due diligence where you have to do a certain amount of basic things before you get a net effect of actually lifting off that curve and getting a real benefit. If you don't have antivirus, if you don't have firewalls, if you don't have the basic stuff down, which we're going to cover in the next couple of slides, you don't get to the point of due diligence. Commercial reasonability is where you're trying to get to. That's the point where you've spent a certain amount of money, you're getting the most bang for your buck out of it without having gotten to the point where you're spending millions and millions to get very little benefit. So there's that diminishing returns point. So the way that the environment is affecting this is that the attacker's tools are always getting cheaper, more sophisticated, more automated. And what we're trying to do, and our goal here in this talk, is to get better defenses that require the attacks to be more sophisticated so they can't get away with just a cheapy shortcut, and to make them cheaper and easier to use. And to that end, we want to take that curve, we want to bend it up, and we want to bend it left so that you're getting more bang for your buck from what you're doing with your security resources, time, and money. So the way we see the due diligence, the way you get there, is through the principle of least privilege. You want to limit your admin privileges, both local admin as well as domain admin. So you don't want to be domain admin, you don't want to be logging in as domain admin unless you're actually doing something to change the domain, something that requires it. If you're just managing accounts, you don't need to be domain admin. Limit the local administrator. Being a local administrator on an administrative workstation means that you're at risk of putting malware on there that can compromise your account and other accounts. Reduce risky behavior. Don't email and don't allow internet browsing on your administrative workstations. You can do intranet because you more than likely have switches and devices and other things you have to manage through a browser. Great, but do you need to actually go out to the public internet and put all those risks on an administrative workstation? Probably not. Do you have a question, sir? The question is, does UAC suffice for least privilege?
Yes, what we're suggesting is that the administrator doesn't escalate. The administrative user does not have the opportunity to escalate. And the reason is because if they can just click OK, or if they can, type in their password and escalate to full admin, then the reason that they're escalating is because something is going to happen on that client. And that is probably code installation.
And to clarify, we differentiate between needing local admin to use it versus not needing it. And what we're saying is if you don't need it, according to the principle of least privilege, don't give them that permission. If they absolutely need to administer on that local box, UAC is an extra step to help do it.
Yeah, generally we're trying to prevent accidental compromise. It's not that we don't trust the administrators. We trust them. Clearly they're administrators, and they're skilled for that task. But a lot of times, we say don't browse to the internet. Well, maybe they will, or maybe they're going to get infected documents from a share internally. We've seen that happen. So the risk is that an infection will come in, and we don't want the infection to run such that it will compromise their entire workstation. If it runs, it has to run in a normal user context. So that's normal. It's still bad because that user context is administrator on a remote server, but at least it won't infect the client if they can't elevate to admin on the client.
Yeah, when you have that local admin, you can install local services, you can stick to that box. But if you're just a user on that box, your options for staying there as a bad actor trying to get on are much less. And of course, there is no panacea in security, so these are just things that make it harder for the attacker and drive their costs up and their benefits down. We also recommend, as part of due diligence, a hardened client. Run 64-bit of the latest operating system. 64-bit, you have things that we couldn't do as Microsoft, as the operating system vendor in the 32-bit space. Requiring signed kernel drivers was not a bar that we could make happen in 32. When we introduced 64, we could. What are some of the other ones? Processor enforced depth.
Yeah,
there's
the
several
processor
things that
enforced
you
depth's
get.
a big one. Yeah.
So going 64-bit, going to the latest OS, all the lessons that are learned, some of them from Solomon's tool, on how to build an operating system, how to build it better, all those things are incorporated in the next release cycle to make it better from the get-go. And again, there's certain things you can't do on a shipping product that you can do on the new one. And of course, patching, antivirus, anti-malware, and firewall you definitely want to include. And William's going to talk specifically around baselines and security compliance manager and how that, having that known set of secure baselines sets you up for that level of due diligence where you've got good coverage.
So how many folks, I know there was a few that had put up their hand for security compliance manager, but how many folks have a baseline, an actual security template that's deployed in their environment? Okay,
Nice.
Still just a few. So there was another talk earlier in the week called Implementing a Security Baseline. So if you get a chance, go back and look at the materials for that. That'll go into detail, more detail than we'll do here, about how to design a baseline, test a baseline, and so forth.
So that next step, that getting to between due diligence and getting a commercial reasonability, one of which we won't talk about in the talk, and the other three we will. Require two-factor authentication. Does everybody here know what the three factors of authentication are? Anybody not know? All right. What you know, which is something you can type into a keyboard, any automated program could do, something like a username, a password, stuff that's purely electronic. What you have, something physical, like an RSA token, a smart card, anything else that cannot be physically separated from the device, and there's only one copy of it. And then what you are, which is biometrics, fingerprints, retinas, and those type of things. Having that two-factor authentication where you're bridging those two worlds is a massive increase in security. And so that's something that we do recommend. We're not going to cover it too much in this talk, but it is a recommendation. The three tools we're going to talk about are Emmet, which protects you against exploits by unknown malware and known malware. AppLocker for whitelisting which applications can and cannot launch. And Attack Surface Analyzer, which allows you to see your attack surface, address it, and measure fixing it, which Solomon's going to cover much deeper than that. So on the cybersecurity team, the way we kind of look at this problem space is there's four kinds of solutions that we're working on developing. We don't have anything to announce or show today, but this is the direction that we're going. We want to work on protecting your assets, which is going to cover pretty much all of the technologies we're doing today. So you want to put those in place. That's people, process, technology. We want to detect when something actually happens. That is primarily a tools-based, although there has to be supporting process so that when you detect something, how do you respond to it? What types of events, when they come up, what do you do? And what tools do you use? What's in your toolkit? And then recover, how do you bring back to the point where you've got that CIA triangle back, that confidentiality, integrity, and availability, and you've got a running system.
So if we look at what we're going to try to achieve today, We've got a typical network with a bunch of users and a bunch of workstations, and then we have workstations that our administrators are going to use. And we're going to try to lock those administrators down and allow those administrators to have a secure desktop. That's what we're trying to build with this technology. The configuration of this desktop is such that the administrative user will only log on to their workstations, their dedicated workstations, with their admin accounts. Okay? So one of the ways we can achieve that is use a virtual machine. So it's very cheap for us to stand up a virtual machine that the admin uses for admin activities. They may have another account that they can log on for other purposes on normal workstations and browse the internet, but we're trying to create a barrier so that the administrative workstations don't directly go to the internet. If they need to go to the internet, then they move things to a file server, go back to their administrative workstation and pull stuff off the file server. Okay? So what this was saying was that we don't really want administrators to log on to user workstations. And the reason for that is those user workstations may already be compromised. So if the administrator logs on, does a desktop logon to the regular user workstation, then malware will now have the privilege of that administrator. So that's sort of a worst case scenario. So we can do this with group policy and make sure that admin users are denied logon opportunity to anything other than their workstations. Okay? So that's what we're trying to achieve in this case, is these trusted admin credentials being isolated and used only on trusted admin workstations. So, I'm going to continue, Mark?
All right.
Okay. No, I'll do it. That's fine.
Yeah.
Yeah.
For it. Yep.
Okay. So we're trying to minimize the risk, right? We're trying to prevent the infection of these clients, limit the damage that can be caused because we don't want code running as a local admin on the workstation, and we don't want code running with administrator privileges in the domain at all, really, right? And then we also want to make this easy to use. Everybody says, yeah, you know, nice apple pie and stuff, but it's too hard to use. Well, hopefully, after this talk, maybe you'll see some techniques. Maybe you can't do all of this, but you can do some of it. Some of it's better than none of it. What we have in the talk is basically a dedicated virtual machine. It could be a virtual PC image running on a normal desktop, or it could be a 64-bit Win7 image running on a Hyper-V server. We're trying to make this easy to use, so we're not trying to do anything esoteric like make this a non-domain join machine. We're going to join it to the domain, and the admin's just going to be able to log on. But it's only going to be able to log on to that particular management workstation. And then we're going to use group policy to create something called a specialized security limited functionality baseline. So we're going to lock it down pretty tight, and we're doing that because the admin has certain activities they need to do as an admin user, and they should use a different machine as a normal user to go out on the internet. Okay, so I'll just breeze through this kind of briefly. There's not a lot of detail here, but we're trying to create the idea of a server admin. There's a lot more server admins and application admins in the organization than there are domain admins. So the first thing to do is not make everybody a domain admin. And I know that might be hard in your environment, but if you can do nothing else, try to create these concepts of server admins as opposed to domain admin. And then it would be nice because as soon as that user starts using that privileged account, we don't want malware running in the context of that privileged account. So we're trying not to make them a local admin on the client. So I already mentioned the login restrictions. We do expect to have a browser on the client because you're going to need to use that browser to get to internal websites. And then if we can, we'd like to lock down the user login to two-factor. I use a smart card for domain login. And we tried really hard to get the smart card demo working, but all of the rest of the stuff that we did get working took enough time that we just didn't have a chance to do smart cards yet. So in a future version of this talk, we'll be able to show you the smart cards and show how easy it is to create your own smart cards. Okay? And so for regular user workstations, again, regular users can log in, but we don't want the domain or the server admins to log on to other workstations because malware running already on those workstations will then have admin privilege.
And a lot of this is sort of acknowledging that admins are human people and they make mistakes. Sometimes they get lazy. And if you have the system enforce the right thing to do, it makes things a lot easier because you don't have to worry about making people remember to do the right thing. The system pushes them to do the right thing. But you have to make doing the right thing easy enough to actually have them do it so they don't fight it.
Right, right. It's not, and every time I present this to customers, they're like, well, we trust our admins. Well, of course, you trust your admins. This is a defensive capability so that as they're doing their job, they don't accidentally get owned and therefore use their admin privilege to own the rest of the domain. I mean, we've seen cases where Active Directory domains have been infected as a result of admins having malware on their workstation. So that was really bad. Okay, so we have a hardened users OU that we created, and we have a hardened workstations OU. Oops. In the users OU, we have Alice as a domain admin, and then we have Bob as a server admin. Under the hardened workstations OU, we have the admin client 01 up there, and then we have hardened workstations that have logon restrictions, and then we have AppLocker and a baseline deployed to that OU. Okay, so I'm going to run through a little bit of Security Compliance Manager. Mark, how are we doing on the, do you have it to show on the screen? Or?
Yep. Give me about 20 seconds.
That's fine. Okay, so Security Compliance Manager. It's a free download for Microsoft. It was developed by the Solution Accelerator team that was formerly a security team, but now they do all kinds of solution accelerators. You can download it. It installs, and what it does is create a workstation for creating security baselines. Security configuration, sort of a GPO authoring tool, if you want to think of it that way. And so what happens is that you can import these baselines and then make copies of the baselines and then edit those copies and then publish those copies and push them out into GPOs in your domain. So this is a dialog that you'll see. When you first start it up, it goes out and it checks against the Microsoft server to find out if there are any new baselines. So these are Microsoft-designed recommended baselines for your deployment. So it'll go and find those automatically for you. You don't have to keep track of whether they're available or not. You can choose which ones to download. Once you download the package, inside that package there's a bunch of different templates, and you can choose which ones you want to use. In this case, I've chosen Windows Server 2008, SSLF, the special security limited functionality one for the domain, and at the very bottom you can create modifiable copies of these. So they come in as read-only so that you always have that reference. But if you want to modify them, you can do that.
Demo's ready if you want to switch over to D.
Okay.
Hit D. So there you go.
Okay. This is my mouse. Great. All right. So we couldn't get out to the internet to find this, to get our updates off this particular machine because this is standalone. Well, we've got to wait here for a second. Checks twice. No.
I love live demos.
Yep. Okay. Let's go back.
All right. Screenshots it is.
Sorry about that.
Let me see if I can fix it.
All right. So what I've done here is you might ask, what's a baseline? I've selected a copy. I've made a modifiable copy of a baseline. And it's just easy. You right-click and say, make a modifiable copy. So I've selected that copy. And what's inside? Well, there's a lot of settings. There's a lot of security settings, as you've probably seen in group policy. And this allows you to review those settings and see what the values are.
It's working now.
Okay, of course. Well, I'm already here, so.
All right.
So if I choose this one particular password policy, for example, I'm looking up here at maximum password age, and I look down, and in order to make a change, I go to the definition tab, and now I can change. I can define this setting, or I can not define it. I can leave it undefined, in which case the defaults will take effect. And if I define it, I can choose, in this case, how long the maximum password age should be, from 90 days or 42 days or whatever. You can also put some comments in, and if you see there's a tab over there, it says threat and countermeasures. So Microsoft released a document that goes through all of the security settings and describes what the risk is if you change this setting, what attacks are used against this setting, and if you change it, what the risk is. So being an admin myself, I admin a whole lot of systems. One of the things that always bugs me, that, and this is to the ease of use, is that when I change my password, I don't want to wait another day to change my password because I'm not a very good password picker. And usually if I have to change my password, I'm going to choose something that's kind of easy, and then I'm going to think about it for a while, and I want to change it to something hard that I know I'm going to remember. So I like to be able to change my password 1 or 2 times a day. It's not that I want to go back to my old password, but this particular setting was getting in my way. So I personally This is not recommended practice, but I personally, on a system, wanted to change this particular setting so I don't have a one-day wait before I can change my password again. So what happened was I read my threats and countermeasures section, and right down there at the very last sentence, it said, if you change this to 0, it will no longer enforce password history. Well, that was an unanticipated consequence. I thought if I just changed it to 0, it would still make me change my password. It would allow me to change my password, but I'd still get password history enforced, so I couldn't change it back to the one I had just used. But it turns out if I set this to 0, then I don't get the benefit of password history checking. So sure enough, this caused a conflict, and I thought we wanted to enforce password history, so I had to escalate this up to Alice, the domain admin, to figure out what to do. So more on that in a moment. What you're seeing here is the ability to compare different baselines. So if I've made any changes, and in this particular case, I haven't made any changes, just one. So I know that that's the only thing I've changed. And I'm getting ready to finalize this, but I had a meeting with Alice, and I'm going to end up winning this argument. This is good. Alice agreed to let me set the password age to 0 so I can change my passwords more frequently than one day. But we just put a comment in the GPO, in this particular setting, that for Bob, the server admin, it was approved, and exactly the date.
How many of you have been in an environment where you were like, why did anybody ever want to change this setting to where it's at? Anyone ever run into that situation?
It's a lot of history.
A little bit of a record here so that you actually know why these things were done and who approved them. It's just a free text field, so you can type in anything you want, but it does give you that tracking on the reasoning for settings being changed, so you can go back and know, oh, it broke this app, or whatever the legit reason is.
So once I've got my baseline together, you create what's called a backup GPO out of the tool, and then you go to your domain, like I've shown here, to group policy objects, and you choose the one that you want to import into, and then you just import the backup GPO into the domain GPO and apply it. And voila, that's pretty much SCM. So there's some steps in here in the slides, and there's a question? Yes, sir. So the question is, can I compare it to a production baseline? Absolutely. Let me go back in the slides. So if I've got my production baseline imported into the SCM workstation, then I can choose any baseline that I want and compare it to what I'm currently using to see the changes. So this counts the changes, but then I can go in and actually look at each detail.
Yep, as long as it's in the database.
Right. Right. So if folks have detailed questions about how to use SCM, I'm happy to take them after the talk, but one more. Yes, sir. Mm-hmm. Yeah, so the whole purpose, right. So the comment was the reason that you want to have a minimum one-day change on the password is so that administrators don't change the password again and again and again to cycle back to their original password, so that thus, you never really change the password in effect. And that I was thinking that no one would really want to change their password 24 times and go to that effort, right? So that's why I wanted to go back to 0 days, because I thought password history would still be enforced. But as it turns out, if you turn off the one-day minimum, you don't get password history at all. So there's an unanticipated consequence for which you should have minimum 1 day turned on, so you have password history. That is the recommended behavior. Okay? So I'm going to turn it over to Mark or do you have?
I have one more observation on SCM. For those of you that are using SCCM, or SCCM's DCM feature, the SCM tool will take these same baselines, and if you didn't notice, there were some scripts in there that it highlighted, and it will actually go and you can import this into the DCM directly in SCCM and check compliance against these on your workstation. So it can push out not only to the GPOs to put them out there, but also to the DCM to do a double check through an independent system to make sure your baseline is configured as you intended, that there wasn't anything that made a machine not be configured like that.
Has anybody used a desired configuration management, DCM, in their environment? A few? Okay. Great. Okay, so now we're going to talk about the Enhanced Mitigation Experience Toolkit, a long name for something that's pretty simple and very cool. Mark?
All right. So a couple of you mentioned that you've used Emmet. I have been an avid Emmet user since the 2.0 version, and we had our slides all built and happy and ready to go for the 2.0 version. And then we found out last night that 2.1 actually got published. So we're like, what changed? We're presenting on this tomorrow. So actually not a whole lot changed. There's been quite a few manageability improvements, and we'll show those in the demo. But for those that don't know what Emmet is, it protects you against unknown vulnerabilities by essentially blocking the exploit techniques as they would be happening on the workstation and causing the applications to crash instead of actually going through with the exploit and executing the code as the bad actor would intend. It blocks new and old apps, Microsoft and third party, or it blocks the techniques against them. It doesn't block the apps. As line of business apps, you don't have to have source code. It didn't have to be compiled with the correct Visual Studio flag. You don't have to have all that. You simply point at the exe, and Emmet will enforce these mitigations upon the exe. On occasion, you will see an app, very rare, that doesn't like this because they're doing something like these exploit techniques within the workings of the apps, but pretty much 99 out of 100 times, the techniques that these are blocking are not legitimate API calls and normal things. So, and just as a testament to how effective this tool is, both Microsoft and Adobe bulletins over the past 6 months have publicly cited, most of these were bulletins that said, hey, there's been an exploit in the wild, we don't have a patch yet, we're working on it. In the meantime, use Emmet to protect your systems, and it will prevent you from getting the malware on your box. It will prevent the exploit from being successful. So that's just a testament to how effective this tool is. So let's demo. So this is the GUI for Emmet. There's also a command line tool, which I'll be showing you in a moment. It's divided into two different areas. The top part here, this is just a nice, convenient GUI way to manage what's already in the operating system. So data execution protection, structured exception handler overwrite protection. I'm actually not stumbling when I say that, which amazes me. And ASLR. I'm not even trying that one. These are built into the OS. These already exist. They vary whether you're in Windows 7, Windows Vista, Windows XP. Some of them are there, some of them are not in the older versions of the OS. But this is just a GUI way to get access to what's already there. The real meat and potatoes, the interesting part of Emmet, is this bottom half, where you can opt in applications. What you see here is simply like a task manager list, so you can see what applications are running Emmet. You can go down to this Configure Apps button and add in the applications that you want to protect. So let's go ahead and protect Adobe Reader. And browsing there. And let's go here. And let's pick the AcroRead 32. And let's also add something I placed on the root of the C drive, a little memory test tool. So at this point, there's a little bang and a note that says, the changes you have made may require restarting your applications. So it just needs an application restart if it's already running. And you'll notice when we launch Adobe Reader here, when it comes up, let's try the refresh button. There we go. It is now protected and says it's running Emmet. And whatever you choose, there are 7, there was 6 Tuesday, now there are 7 as of yesterday's release, protections on these applications. DEP, Data Execution Protection, SEHOP, and ASLR are the same ones built in the OS. However, in addition to what the OS can do, you can enforce them on the apps, as well as 4 that are unique to Emmet. And the documentation covers the details. I don't want to spend too much time on those.
So Emmet acts as sort of a protective wrapper around the application, so that if the application is attacked by malware, it doesn't misbehave and end up causing an exploit.
And as you can see, the apps pretty much run and work normally. So what I've done actually on my box, just to show you how brave I am, is I added star.exe and program files exe or x86 rather, and I've had pretty much no errors. I've actually had a few with some consumer apps, but they're not the type of thing that any respectable IT admin would ever have on his box. So we'll just leave it at that. So next thing I wanted to show you is the command line. You can do the same thing. You just do an emmet_conf, add, and then you can pretty much do all the same management that you could do with the GUI. The other thing that you may not have noticed is when we're configuring the apps, you have the ability to import and export a configuration. So if you have you decide that you're going to do this on your golden master image, you go, you add all the apps in, you test them, you're good to go. If you need to script this onto your machines, you can go ahead and take that XML file and run the emmet_conf tool and import that in there.
So if you're online right now, you could go to microsoft.com/downloads and search for Emmet, E-M-E-T, and you'll see the download. So that'll be the latest version 2.1.
So now let's go run that little memory test tool. So one of the things that it protects against is data execution protection. And in memory, when programs have two different types of memory fundamentally, there's a bunch of types, but some of them are executable, some of them are not. So what we're going to do is we're going to tell this tool to go ahead and write some memory and then attempt to execute it, but we're not going to mark it as executable. And so Emmet will now crash, or rather Emmet will cause this application to crash. If we tried to do this anyway, there wasn't anything in memory, it simply allocates it and tries to execute whatever garbage is there. So it would have crashed in a different way in this app. But the reason that I ran this was to show you what it looks like when Emmet actually does its job. And one of the key things to remember is that Emmet is, in those cases of those three protections, is causing the application to simply crash. It's not like there's a little log file that says this happens. It's telling the OS to impose these protections on the application. So what you're going to get is a pretty generic crash message that says, with an exception code, that basically means access violation.
But
So
at least that application, if it were malware, it would have crashed, right? As opposed to exploited the system. So that's the protection that Emmet's providing the applications that you opt in.
Yep. And the thing is that the reporting piece is weak, the management piece is weak, but the actual defenses are extremely strong, extremely effective, and it's a great tool to add as a layer of protection on your workstations. And one of the ways you can overcome this challenge of going out and finding these is for those that have MDOP with software assurance, or that have SCOM in their environment where you're collecting all these error reports, if you send them all to one place in one database, you can do the analysis on it and look for the access violations, look for a pattern, and then start looking at it. So that's one way to centralize it. So let's go ahead and switch back to the slides.
Okay.
So like I said, there's some limits on what information on what Emmet did. Which leads you to sometimes disable and enable Emmet to figure out if an application is legitimately crashing. Again, issues with Emmet are very rare. An enterprise management challenge, and of course the OS mitigations vary with the pre-Windows 7 clients. And that note there about Emmet DLL showing as faulting, that usually only happens with the Emmet-specific applications where you would see in that crash message that the Emmet DLL was cited. So. I think we have one more slide on this.
Yep.
So Emmet is extremely applicable to both administrative and enterprise workstations. You do have that command line install and configure. You can use the desktop error monitoring or application exception monitoring. Identical feature, 2 names, 2 places. And what I've pretty much done for geeks like us is to add pretty much everything in my program files.
So we'd expect everybody here could download Emmet and just set it up and run it on your workstation. We haven't noticed any problems, at least on ours. Yes, sir. Right. So the question is, how do you differentiate an attack on an application versus a compatibility question or a compatibility issue? The answer is if you can launch the app, clearly it runs, right? And you put Emmet on the app or opt the app into Emmet protection and you launch it and it crashes, right away you know that that's Emmet doing it because it's a simple on-off test. More likely what will happen is some function within the application, buried down, some left click, right click thing that it's trying to do will end up causing it to crash. Now that's only, I have never seen my apps crash because of Emmet, and I run a fair number of things. Mark's also been running this on all of his EXEs and not seen any crashes. Again, Emmet is looking for very weird malware-like behavior and trying to protect that and prevent that behavior. So unless the application is doing some really weird stuff, like maybe an antivirus application, I would be careful about putting Emmet on an antivirus application because they do some very weird things. But normal applications should be totally fine. The nice thing is that we didn't get to the support alias, I guess. There's a support alias that provides support for Emmet. And also, I think they're coming out with releases. I can't say exactly what the release schedule is. We didn't know about the 2.1 until yesterday. But as they find problems, they fix them as fast as they can. I'd say, you think, well, I'm just hearing about this, but the release of Emmet was last year, and it's had, I don't know, how many, do you remember, Solomon, how many downloads? Matt?
50,000?
Yeah, so
100,000.
over 100,000, and who knows how many systems that was deployed to. But being available globally for a free download, there's a lot of coverage on this, and there's a lot of feedback coming back into the product team. So the fact that it was the only way to mitigate some of the zero-day attacks until the patches came out really picked up our attention. And that's when we said we have to start evangelizing this and telling customers about it and getting them to try this, because if that's your only zero-day mitigation, well, you better try it, especially on your admin workstations. So, yes, ma'am.
No, the question was around degradation of performance, and I have noticed absolutely none. It's simply just watching for these certain weird things, like injecting parts, like heap spray. It injects a bunch of random code into memory. Emmet doesn't allow that to happen. Trying to execute against a page in memory that is not executable is the depth thing. So all these things are specific low-level activities that a normal application wouldn't do, so Emmet just kind of stays out of the way for most operations, yeah.
Okay.
So, AppLocker. Anyone here, we've had some hands earlier, AppLocker usage? Anybody actually using it actively or just playing with it?
A few.
Okay,
Great.
we have a few folks that are actually using it. So anyone ever mess with software restriction policies, AppLocker's predecessor? Anybody find those easy or hard to use? Hard.
Hard, mixed.
So AppLocker was a big step forward. We think that on an administrative workstation, this is a very reachable goal because the amount of applications and server tools that you have to use on an administrative workstation are actually relatively low. Enterprise workstation is a different story because you have to know your whole catalog and what apps are out there. So it's a little bit more of a challenge, but still, the AppLocker improvements in usability, we think, put it within reach of a usable everyday security tool. So whitelisting, the difference between that and a signature or blacklisting approach is simply that what you don't know about in a whitelist approach doesn't run. There's a deny rule that's implied at the end of it. So the publishing rules is the big piece that moved AppLocker forward beyond SRP, and it's a Windows 7 feature that you manage through group policy. So we'll be showing that.
Just to repeat, it's a lot easier now than it ever used to be. Let's switch over to the demo. Because, is that it? Okay. Because before, with software restriction policies, and Mark and I suffered with this, you had to go in and know all of the applications and type in all the paths, and it was really, really hard. With Win 7, and they renamed software restriction policies to AppLocker and made a bunch of improvements on it, now creating the policies is very, very easy. There's a wizard that runs, Mark's going to show you that wizard, that just finds all the applications that are on an example image and then creates the policy automatically for you. So it's really easy.
So this is an administrative desktop, and just to show you a little bit of protection against my own stupidity, I just tried to log in as Bob User, the normal user account, and it just told me you can't log in because a logon method isn't allowed. Users can't log into administrative workstations. So just figured I'd show you what that experience was real quick. Let's go ahead and put the right one in. Bob Server Admin. And it'll let us on there. So there's a couple things that you want to let normal, in this case, server administrators do on the workstation. How many of you do not manage your IPs in a spreadsheet? Wow. Cool. So I didn't realize anybody used something else. So there are certain cases where you'd want to use certain Office applications on administrative workstations. Technical documents, how to do installs. These type of things you definitely want to run. However, PowerPoints, much less so. You don't want that to be running on your administrative desktop. So what we want to do, and I'm going to go ahead and switch over and show you how to do some AppLocker policies to block that. And I'm loving this resolution.
It's just our, you know, if PowerPoint's something that your admins need, clearly you can run PowerPoint. We're just using this as an example.
Yep. And so the way we've got the domain set up here is we've got the hardened workstations, which is where our administrative workstation lives. And we've got the SSLF GPO, which has a number of settings in it that William set up using SCM. We have the logon restrictions, which restrict the user logon rights, as you just saw. And now what we're going to do is we're going to go ahead and create a new, or we're going to take a look at a test GPO here, and I'll show you how easy it is to create AppLocker policies, or AppLocker rules.
So is this an empty GPO, Mark?
This is either an empty GPO or one that I will empty very quickly before anyone notices. I can't remember if I reset the demo or not, so I will double check that. And it is going to be empty very soon. In fact, it is empty now. So this is an empty GPO. Hey, go away. All right, this is an empty GPO, no AppLocker rules. So the way you start out making an AppLocker rule set is the easiest way to do it is to create default rules. Default rules basically say any local admin that is a local admin on the box can run anything on the box. It's a path rule, so it's just anything in the whole path. Specifically the whole machine. Then there's two rules for users. The first is all files located in the program files, and the second is all files located in the Windows folder. So this is a good starting point. It's not the end state that you want to be at. It's not that restricted lockdown, prevent a bunch of unknown stuff, because if they can write to program files, it will then execute, and it's executable assuming the ACLs and whatnot are in place. So the next step is to take this high-risk one and make it more granular. So the program files folder is the one that we want to replace. We'll leave that in there for the moment, and we'll show you another wizard that makes your life a lot easier. It's, let me see if the zoom it works. Nope. This automatically generate rules will allow you to generate a rule set. Cool thing about this is you just tell it a folder, in our case, program files. And one caveat where this demo differs from reality. I'm running this on a DC, so there's not many programs installed. There's not Media Player. There's not the things you would normally find on a workstation. So this is going to be a slightly smaller scan. But the way you would normally want to do this is you build a workstation that's got the base image that you want, all the apps that you would ever want to authorize on it, and then you have it scan that. But we're going to go with what we got right now. We're going to call it the program file rules.
We got like 2 minutes, Mark.
Thank you. And you create, and what this does by default is it create publisher rules. Well, it can for anything that's signed. Where it can't, it will create a path rule. And so these are the rules it's going to create. I'm going to go ahead and create them. And now we have a much more granular view of our program files where everything on the server is signed. So it's all publisher rules. But if you had unsigned applications, it would also do, path rules for those. And at this point, you can now delete the program file folders. So we've already got kind of like a cooking show demo where we have a fully baked pie at the end, even though we're still cutting apples. So let's show you the final GPO real quick, and then we'll show it being enforced. Let's go ahead and link it. So we're going to take our reference GPO, and we're going to link that, and fully baked in the oven, give you a quick view of the rules. And then if we're lucky, we'll actually see an enforcement. Did I mention I'm superstitious about demos? So app locker. Keep going. And this is a more fully complete rule set that I created on the clients. And one thing I wanted to point out very quickly is you have this exceptions. You notice there's a column there. When you want to say, I want everything in Office except for PowerPoint, you can create exception rules. And in this case, I'm blocking Outlook, and I'm also blocking PowerPoint. So let's go ahead and enforce these on the client real quick. Let's do a GP update. So the applications that should still be running are running, and it sometimes takes about 10 or 15 seconds to take effect, and there we go. Program is blocked by group policy, and he can no longer run PowerPoint, which was explicitly disallowed by the app locker rules.
Yay.
It worked.
That was easy.
Live. It was pretty easy.
Oh, first live demo. Okay, so let's, we'll go back to the slides here, and we're going to turn it over to Solomon. There's some more, oops, I'm dropping out. There's some more detail in the slides, but we're going to turn it over to Solomon so you've got time to see Attack Surface Analyzer. So Solomon?
Thank you. So I think before we asked if anyone had seen Attack Surface Analyzer. Anyone in the audience? No? We have one. So my name is Solomon Luhi. I'm the program manager in Trustworthy Computing Security Tools team. Out of our team comes tools like Emmet and Attack Surface Analyzer. I'm the program manager specifically for the Attack Surface Analyzer tool. And what Attack Surface Analyzer does is identifies changes in system state and secureable objects in the Windows platform. Now, how is that related to securing our admin desktop? So one of the things we're looking for with Attack Surface is code that can be run by unauthenticated users, but also we want to look at elevation of privilege issues. So once someone does get onto your machine, we make sure that they're not potentially going to be able to elevate privilege to administrator or do something which could be as part of further compromise, or as marketing folk would like to say, part of the advanced persistent threat. So I'm going to use my deck a little bit like flashcards because we're a little low on time, and I respect your time being it's the last talk of the day. So I'll start off, and if you have any questions, I'll try and answer those at the end, so at least the people who need to get out on time can do so. In the case of the tool for a demo, I'll show you through some screenshots just to start with, and then if anyone wants to stay around after the talk, then I can walk through the report as it normally would look. So Attack Surface Analyzer is useful for IT pros, system administrators, and also for developers within your IT department. So if they develop an app, to ensure that that app is reasonably secure and doesn't bring unintended changes to your attack surface, you can use Attack Surface Analyzer for that. It's also a bit of a Swiss Army knife for IT security auditors, and also in the case of doing IT security incident response, you can use Attack Surface Analyzer. Attack Surface Analyzer fits very well into Microsoft's SDL process, and this is the standard SDL slide. You are more than welcome to go and download the simplified implementation of the SDL for your internal devs. And there's actually a lot of value here also for IT pros. We don't market it that way, but in the case of things like doing threat modeling, if you're building a gold image that you're going to deploy or your admin desktop, you may want to actually consider when you're doing your threat risk assessment, what does the threat model actually look like with this machine on my network? So as I mentioned, Attack Surface really is code that can be run by those unauthenticated users. And Attack Surface Reduction is trying to reduce those areas of attack or attack vectors on the platform. The great thing about Attack Surface Analyzer, just like Emmet and the other tools that come out of our security engineering team, is it's free. You're more than welcome to use it within your organization. Likewise, if you're a consulting firm, you can use it royalty-free. It enables you to really improve the security of your system by closing down the attack surface. And within Microsoft, we've used it for over 5 years, or some incarnation of the tool. All of our products must, before they can ship outside the company, go through an attack surface analysis phase. And the real sort of benefit of the tool, and we find this inside Microsoft, and hopefully you would find it in your organization as well, is it saves time. So you might be presented with some kind of audit that says, I need to make sure that there's not unnecessary ports running on a box. So sure, you can sit there and run netstat minus A&O on every box in your enterprise and try and put it into a spreadsheet and manipulate it. And then when the audit manager comes and asks for, well, what's the provenance and what is this artifact, and you have to try and explain to them what the netstat command does. Attack Surface Analyzer is sort of starting to become understood now. We released it a few months ago. And you can put aside basically the collections that we take off the machine and use them as artifacts in the future if you need to refer back to what did the attack surface look like. So the area that I said that the tool puts a lot of focus on is securable objects. That are things which are on the Windows platform that can have some kind of access control list or security control applied to them. And most people will think back that, oh, yeah, access control list, I remember, that relates to the file system or that relates to a registry key. But in fact, in the case of the Windows platform, there's a whole host of objects that can have security descriptors applied to them. Things like named pipes, your desktop, COM controls, DCOM. And so what we try to do is bring that together in the tool to give you a better understanding of what does your attack surface look like. And in the case of badly ACLed objects or objects that have a weak access control list applied, call those out so you can look at if you want to accept that risk or take some sort of steps to mitigate that risk to reduce the opportunity for elevation of privilege. How are objects secured? We talked about files. So the file system, everyone would have seen probably the CACLS command, or it's now ICACLS to cover integrity levels. Of course, everyone here will be familiar with registry editor for the registry. But then there's a number of other objects, as I mentioned, that how do you set access control lists? Services are a good example. You can actually set an access control list on a service individually, but nowhere in Windows do we give you the opportunity to do that unless you call an API directly. So how many system administrators here are trying to whack out a C# script to change their access control list on a service? Probably zero. So Attack Surface Analyzer will highlight these sort of weaknesses. And you can also use, we've included in the deck a few other reference tools that might be of interest. One is called Sub in ACL. It's a tool that's also available on the Download Center, and it allows you to enumerate security information about securable objects, including services, and also to set them. So if you want to do some testing, or maybe you've found that, oh, you installed application X from vendor Y, and it does have an access control list you're not happy with, you could use Subinacle as part of your deployment scripts to actually then do a post-install step and actually tighten that up for you. Security privileges. On Windows, there are a lot of security privileges, and the list is pretty extensive. Most people sort of look at it and go, yeah, that looks all right in the security profile manager. Well, or security policy editor, sorry. A few of these are sensitive. A few of these could lead to elevation privilege. Things like debug programs, SE security privilege. So this is the sort of typical way that you would see how those privileges are. If we notice when we do a scan of the system that you have user accounts or groups that have these privileges assigned to them that we think could lead to elevation privilege or weakness on the platform, we'll call those out later in the attack surface report as well. So, newer is better. Unfortunately, we don't support the likes of NT351 or NT4 anymore. So you can run the GUI, the UI on Windows 7 and Server 2008 R2. It does require .NET 3.5. In the case of the older platforms, Vista and Server 2008, we have a command line collector. So you can't actually do the analysis piece. So in some organizations where the majority of your infrastructure is still on an older platform, like Server 2008, you can run the collection, take those snapshots, and then do some analysis on a newer machine like Windows 7. And as we move forward, just the last point there, if Microsoft releases a future version of Windows, then you would need to get a new version of the tool. For our analysis, we're backwards compatible, so if Microsoft was to release a new version of Windows and we release a new version of the tool, your old collections that you've taken will still be analyzable into the future. The process is pretty straightforward. You simply take a snapshot A snapshot will run anywhere from 5 to 25 minutes, depending on what's on your machine. Then you make some changes, install some products, make some config changes, install some line of business apps, or in the case of your admin desktops, you might be installing the system that's required for your imaging, like Arturis, or for maybe your printer management solution. Excuse my pronunciation, I'm Australian, so sometimes the I's and the vowels don't come out the same. Then we take our next snapshot, and we consider that the product snapshot. So for the software developers, this would be after, or internal sort of IT departments, this would be after they've just installed their little product and done the test. But in the admin desktop scenario, and more broadly in your organization on desktops and servers, you can actually decide how many snapshots you want to take. You might decide, I'm going to take my baseline once I've just dropped down the gold image. Then I'm going to install some Microsoft products. Maybe I don't trust Microsoft. What are they doing? Take a snapshot. Then you're going to install our third-party apps. Maybe you have a PDF reader or a writer or some other bits and pieces. Take a snapshot, and maybe your line of business apps. And then you can either analyze from the baseline to the final snapshot, and that will give you an aggregate view. And if you were to find issues and wanted to narrow those down, you could actually sort of break down through those snapshots that you took through the build process to identify exactly where these weaknesses are coming from. And then you can make a business decision on if you're willing to accept the risk of having that particular component as part of your admin desktop or your environment. With the command line version of the tool, which runs only on the older platforms, but also is supported on the newer platforms like R2 and Win7, you can now use those to take scheduled snapshots of your high-value assets, maybe machines that are further out on the network perimeter, closer to the internet, or your sort of DMZ scenario, so you can get an understanding as time goes on if this attack surface changes. At least you can archive those internally, and as I said, you'll have an artifact for auditing if something was to go wrong, or if you want to just keep an eye on that over time. If we were going to use the tool, Attack Surface Analyzer, for incident response, the one thing we need to make sure is that we have a known good baseline configuration. And so we would do that by, once we deploy our box, install our box and deploy it, then we take these snapshots and move them off. And as I said, you can use something like Task Scheduler. With the next version of the tool, when we rev it, we're looking at an NT service model, so you could have not only could you just have a scheduled task to drive it, but you could actually have an NT service that would run to do these collections for you. Now a little nugget because you've been patient and stayed with us this late on the last day. Attack Surface Analyzer is quite a broad tool as it's used within Microsoft, and we released basically a subset of the tool which specifically looks at the Windows platform externally. And we have a plugin model that we use internally. One of those tools that we plug in actually is called AutoRuns SC, the command line version of AutoRuns from Mark Rasinovich, a sysinternals tool. And we hadn't quite got all of our ducks in a row and the planets lined up, so we didn't ship the AutoRuns binary with Attack Surface Analyzer as it came because we couldn't get our EULAs matched. But you can actually take the AutoRuns executable and drop it into Program Files Attack Surface Analyzer lib directory. As you see, I always like to verify my copies with a /v. So you can drop it into the lib directory, and what will happen is when you run the collector, it will recognize that AutoRuns is there. It will actually spawn off the AutoRuns task. You'll see it come up on the task list, and then later when you go to do your analysis, you'll get AutoRuns information included in your analysis. So this deck will be online for attendees after the talk, so you can grab the exact syntax or the path if you're interested there. Okay. So this is the demo section, but as I mentioned, I have some screenshots. I'll zip through those first, and then at least that'll give us some time at the end for questions, and those who are interested, I can go through the report later in a little more detail. So a very complicated method to start an application, as I'm sure you've all seen the Start menu before. Start Attack Surface Analyzer. Assuming that you've installed using the MSI, there is one thing to note, is that Attack Surface Analyzer doesn't require any change to the system state it's installed on. So you can actually just X-copy the bits across to a machine you want to do your analysis from. If you're a little unsure as to what we're going to install, you can just X-copy those across, run it, delete it. If you do run the MSI, you'll get the nice little icon in the Start menu, kick it off, and then you get a very complicated GUI. As you'll see in the security team, we're not big on UI, so just like Emmett, Attack Surface Analyzer is pretty simple. We just choose Run a New Scan, and down the bottom there, Run Scan. Once we kick it off, you'll see the task list populate with the checks that we're going through and enumerate what secureable objects we're enumerating, what security data or privilege information we're looking for. And as I said, this is somewhere in the order of sort of 5 to 25 minutes. Clean machine will be about 5 or 7 minutes.
Solomon, can you just read through some of those things so folks, it might be too hard to see what it's looking for? Because that's the cool thing. I mean, this tool looks for all kinds of settings on the system that you would never be able to go through manually.
So obviously the basics where we think about access control lists, which is files and registry keys. We also look at things like memory pages, Windows. We look at firewall settings. So if you're using the Windows inbuilt firewall and hopefully you're also using Internet Explorer as your default browser, then we'll collect some security settings there about how your IE is configured. If you are not using either the Windows firewall as your firewall or IE not as the default browser, we won't warn about that. We're pretty agnostic in security. As long as you're secure, we don't mind. But you should then obviously go and find the security best practice guides from whichever vendor you're using there. As I mentioned, we had auto runs, so we've dropped in the auto runs now. Auto runs task is actually executing and complete. It also looks at things like processes, which can have access control lists assigned, threads that get spawned off as part of those processes, and my favorite one that we don't provide a way to change access control lists for, services. Once the scan is complete, you'll see the lovely window on the right there, scan complete. It'll tell you where it wrote out the data to. And basically what we do is we take all of the data, it's a collection of XML files, and we compress it into a CAB file, which is Microsoft's version of zip. You can click on the name there and it will open up, or Explorer will by default open up a CAB file. So you can see what actually was collected if you're interested. But just in isolation, there's a lot of data there that doesn't make too much sense. It's really once we get to the analysis phase where this comes into its own. Once our scan is complete, we've made our changes. We went and we installed, on our admin desktop, we installed our printer management suite. We installed our applications we need as administrators to manage the imaging of our machines in our environment, maybe. We installed things like our PDF reader or maybe even Microsoft Office. We came back in, we ran another scan, data collection has finished, and then as we'll see, as I mentioned before, basically there's the file at the top, the CAB file that contains the data. But this time we're going to click Generate an Attack Surface Report. And the report file name there is just a directory where a HTML report will be outputted. For those of you who don't use Internet Explorer, you can open it in the favorite browser of your choice. We're going to click Generate. At that point, once the report is generated, if you have a default handler for HTML, so most workstations have this, some hardened servers don't have this, then it will spawn your browser for you. And like all good things, trust us. When it says here we're going to run active content, what we're actually doing is we have some JavaScript in the report. So you need to allow block content in order to actually have the report render. If the report file was sitting on a network share, actually you wouldn't get this prompt, and that's simply because as part of our hardening of the Internet Explorer browser, for things that run in the local computer security zone, we disabled JavaScript some time ago. So you can either click the allow button and trust us, or you can just copy it onto a network share and IE will magically open it for you. Once we clicked accept, we get 3 tabs in the report. Those 3 tabs, first one's pretty boring, just the report summary. Which CAB files did we actually compare to generate this report? Which machine did it run on? What were the run times? We can then move on to the security issues tab. Now the security issues tab is, you'll have 2 sets of issues here, severity 1 and severity 2. Severity 1 issues, if they're discovered in a Microsoft product, traditionally should stop that product from shipping outside the company. So if a product team sees a Sev 1 issue, it's generally their responsibility, unless they get the CVP, Corporate Vice President approval, to actually close down these issues. Now there is there's actually 2 bugs in the tool. We did release a beta, so it's not fully baked yet. There are 2 bugs. One of them I'll point out here, which is you may see some issues generated from the trusted installer account. Trusted installer is actually part of the trusted computing base of Windows. It's like an internal security principle. We tried to be very, very transparent with the tool and make sure we didn't suppress any security issues and make sure we weren't masking anything that was happening under the hood. Unfortunately, with this one, it's a little bit noisy because when you install something using the installer, things get ACLed, and some people sort of read that and were like, oh, is there a security problem? So that's a false positive you can safely ignore, the trusted installer. And these are really those issues that can lead to that elevation of privilege. So maybe a binary that's accessible by Bob server admin, when we go back to our sort of enterprise desktop case, an executable that's accessible by Bob server admin is actually writable maybe by everyone. And so what does this mean is that if someone can overwrite that binary with some malicious code, when Bob server admin logs on, if he was to actually execute that binary, it would now be executing with his security privileges and could lead to a compromise or elevation of privilege. And that really is why we're talking about all of these layers. They're really defense in depth, because if then Bob server admin wasn't a local admin on his box, that would also help protect against that particular weakness. But there's a lot of those that the tool will pull out. Also things like accounts that have had sensitive security privileges added, they'd come here in our security issues. And then the last tab is the attack surface tab, and this is really all areas that we consider to be interesting from a security perspective, where changes have taken place that you really should take a look at. There's no actionable data here, but this catalogues what those changes are. And an example might be a new ActiveX control was installed. You might wonder, well, why is that interesting? There's a small explain link on the top of each section. We'll take you off to some internal help, which just gives you a paragraph or two, and usually a link off to MSDN or TechNet, where you can then make a business decision if that's a risk that you're willing to accept. Down here is another example, like file registration. So just like when you try and double-click something that's a .docx, here we've got a .abc test, and then what actually will that run? It would link back to whatever binary would be instantiated. So, what happens if you run the tool, something goes wrong? The first step is to check out the SDL Tools forum. You can post your questions there. If you were to find a problem with the tool and it's really blocking you, you are more than welcome to send us an email to ASA, Attack Surface Analyzer, @microsoft.com. Obviously, we've got quite a bit of traffic over the last few months, so can't promise a response to every email, but we certainly will try. And if we see trending coming in with some bugs, then definitely there'll be bugs that we'll get on to fix. And you may want to also look at establishing a small sort of security group internally of subject matter experts that you can sort of talk to and discuss. Now, there is one favor I have for you on this slide, and that is if you were to run the tool and you believe that it's showing an issue with a Microsoft product, then please feel free and please do send us an email to secure@microsoft.com. Those guys are guaranteed to respond to you, and they will let you know if, that does look like it's a security issue with the Microsoft product, or maybe it's a false positive. So onto our summary and references.
Right. So we hope that we've demonstrated how to use free tools to create a secure admin workstation. So we want to open the floor for questions. I know we're right at the end of time, so I want to first thank everybody for attending. And please come up and talk to us afterwards if you'd like to. Thanks.
And one favor to ask, there is, as you've probably seen, the evaluation of tracks, the form that you do. Because there's only been a small audience here today, we would ask that a number of you could please do that for us. That helps to make sure that the content we deliver at these conferences is the most relevant, and also that we're providing the best speakers to you guys. So if you thought the talk was great, you thought that our presentation style was great, absolutely, please rate us that way. If you think the opposite, please do the same and please rate us as well. So at least TechEd can make sure that you always get the best experience when you come here for the week.
Great, thank you.
Thank you.